Question number 6. This is the last question of this paper. This question is of from permutations and combinations, but the part A of this question is of combination. In a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. Total people 25, 6 swimmers, 8 cyclists, 11 runners. Each person competes uh, in only one of these sports. A team of 7 people is selected. Selected words. Selected word indicates that the question is of combination because there is no specific order in this part. A team of 7 people is selected from these 25 people to take part in the competition. Part A is find the number of different ways. Find the number of different ways in which team of 7 can be selected. If means that there is a restriction. If it consists of exactly one swimmer, at least 4 cyclists, and at most 2 runners. These are 3 words. Exactly one swimmer. This is very clear. Total swimmers 6. We can take only one, exactly one swimmer. 61. At least 4 mean greater than or equal to 4. At least 4 mean greater than or equal to 4. But at most 2 runners, this means that x is less than or equal to 2. X can take value 2, 1 or 0. So swimmer is with this swimmer word is exactly there. So exactly, at least, at most. These are 3 words. So we are writing first the number of swimmers. S stand for swimmers. Swimmers are 6. Total people 25. Swimmers 6. Cyclists 8. 11 runners we are writing here. Swimmers 6. Cyclists 8. Runners 11. Total 25. Total people 25. It is given. Now we will first we have to find the number of ways by first we apply these restrictions. These are the restrictions. One swimmer, at least exactly one swimmer, at least 4 cyclists, at most 2 runners. There will be different options to adjust these restrictions. Exactly one swimmer mean total swimmers are 6. So we will take 6. We'll write here 6C1. 6C1 into at least 4 cyclists. Cyclist total cyclist 8. We will write here 8C4. Now at most 2 runners mean Maximum runners will be 2. We can total runners are 11, so we are taking 11 C2. Look at this. 2 plus 4 plus 1. These are 7. This is the first option. The second option will be no 6C1. This is fixed because we can take only one from swimmer. At least 4 cyclists. Here we have taken 4. Now we can take 8C5. Also 8C5 restriction. Next we can take 11 because we have to make total 7 selection of 7 people. 6C1, 8C5. No, from runner total 11. We will take 11 C1. 11C1. And next option will be no 6C1, 8C6, 11C0. 6C, sorry, 8C6. We are taking 6 from 8. These are 1 plus 6, 7. We are not taking from any swimmer because this is a restriction. We at most 2 mean less than or equal to 2. We can take 0 from swimmers. 6 plus 1, 7. This is the option. Third, this is the second option. This is the first option. Now we will use the calculator to find these values. Answer of the first option will be 23100 plus second option is 61 8C5 11C 1. Answer of the second option is 3696 using the calculator. 3696, and the answer of the third option 6C1 8C6 11C0. Answer of the third option is 168. Now we are adding answer of the three options. We get finally the answer is 26964. This is the answer. Now next part of this question is for another competition. A team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. Total 2 plus 3, 5 plus 4. Team of 9 people. 2 swimmers, 3 cyclists, and 4 runners. The team members stand in a line for a photograph. Now this question is of permutation because there is a specific order of arrangement. Arrangement word is there. So find the different how many different arrangements. The team members stand in a line for a photograph. How many different arrangements are there of 9 people? If means there will be a restriction. If the together, swimmers stand together, cyclists stand together, and runners stand together. So this means that there will be 3 different groups: swimmers, cyclists, and runners. So there are 3 groups stand together. So we can write As for swimmers, C for cyclists, R for runners. So S1, since there are two swimmers, we can take S1, S2. These are two swimmers. This is the first group, and the group of cyclists. There are three cyclists. We are making a group C1, C2, C3. This is the second group, and the third group is of runners. There are four runners, so we can write R1, R2, R3, R4. This is the first group, second group, third group. Runners, swimmers are together, cyclists together, runners are together. There are three groups. Now arrangement for first for two swimmers, because they are both swimmers are different. So we can write the arrangement of these two swimmers. We can write two factorial ways. We can arrange in them two swimmers in two factorial ways. Multiplied by for three cyclists, we will write. We can arrange them in three factorial ways. Multiplied by runners are there are four runners. We will write here. We can arrange them in four factorial ways. Now multiply by whole multiplied by 3, 3 factorial. Sorry, these are uh, three groups. We can arrange them in three factorial ways. So we will write here 3 factorial, because now we have to arrange these groups also, because there are three different groups. We can arrange these groups in 3 factorial ways. 3 factorial mean 6 ways. So multiplying these, after calculation, we get the answer is 1728. This is the final answer. 1728 ways. We can arrange them in 1728 ways. Now next part, uh, part C is also from permutations, because arrangement word is visible. How many different arrangements are there of the nine people if none of the cyclists stand next to each other? This is the restriction in the question. Total people 9. Restriction is that none of the cyclists stand next to each other. So arrangement will be of this type. First, we are adjusting the arranging these without cyclist. Cyclists will be adjusted later. First, we arrange swimmers. There are two swimmers, S1, S2, and runners, four runners, R1, R2, R3, R4. Now we have to adjust these cyclists because it is the restriction that none of the cyclists stand next to each other. So we can adjust the cyclists in these places. These are different places for cyclists, so they may stand not next to each other. These are the red dotted places show for the cyclist. So there are 1, 2, 3, 4, 5, 6, and 7. There are 7 places for cyclists. These can be the places of cyclists. Cyclists, two cyclists. There are two cyclists. Sorry, there are three cyclists. In this part, there are three cyclists, two swimmers, and four runners. So we will adjust these three cyclists in these places. These are total 7 places. We have to adjust three cycles, so we will arrange them in 7 P3 ways. So first 7 P3. This is these are the arrangements of a cyclist. Now the arrangement of we can arrange these three cyclists in any three places like this. Okay. 7P3. Now we will arrange these 7 S1, S2, R1, R2, R3, R4. All these are different. So 1, 2, 3, 4, 5, 6. So now we will arrange the remaining S1, S2, R1, R2, R3, R4 in because total 6. There are we will arrange them in 6 factorial ways. After calculating, we get the final answer will be 1, 5, 1, 2, 0, 0. This is the final answer.